Yesterday I summarized the course outline and started a new part. So I want to repeat a few things for emphasis, and this emphasis is about the meeting times. And the meeting times are simply we have the Monday, (11) to 12. We have Tuesday today. That is at 12 to 1. We have the Thursday. That is 5 p.m. to 7 p.m. Course outline is already on the course. Everyone who was here yesterday, I enrolled you to the course. As long as you are enrolled to Mwere, I added you to the course. Now the course is visible in Mwere. I know you haven't been there, but that's what I did. So yesterday we started on electrostatics, and I intend to be a little bit quick on this part. And the 1.0 was Poule's law. Though some of you would like to call it Coulomb. And we discovered that if we have two charges, point charge Q and point charge capital Q, at a distance R between them, and then we take R roof to be the direction unit vector from small q to capital Q. Poule's law is given by, or is said to be, that the force between these two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. And this force is in the direction of the unit direction vector. Now, but this can be written as putting on the proportionality constant k cubed over r squared r roof, and k was found out to be the same as 1 over 4 pi epsilon naught, implying that f will be equal to q small q over 4 pi epsilon naught r squared r roof. And we know that epsilon naught, which is the permittivity of free space, is the same as 8.85 times 10 to the power negative 12 farads per meter. I see people writing. What are you copying? Yesterday's notes. There is a link to the course outline with almost, it's interactive. Each of the parts are having a link. If I say Poule's law, it takes you to Wikipedia, tells you what Poodle did. If I talk of the Gauss's law, it takes you to Wikipedia, shows you what Gauss did, a bunch of other things. So I don't know why you're scared. Concerning what? As usual, actually they're already there because I removed the 2105. some of them may be written on 2105. There's no difference between 3112 and 2105, which was there. The only difference is that this is, oh, I have not said it, the course structure is, you know that one. So the course structure differences between the previous is that this one you have 60% of exam, and then you have 40% coursework, and this 40% includes the marks for pre-prac, the marks for actual practical, the marks for assignment, and the marks for, and as I said, when most of you were not there yesterday, these will be 2 assignments, actually 4, but 2 to be considered. So, yes. And then 2 tests. So, this pre-prac, you are now experts, I believe. You started doing this in first year. Is that you go research about the practical, and during your research you can, approach any member of the staff, not necessarily me alone who teaches the course. You can approach anybody else to get information about the practical if there is anything that you don't understand. And by the time you come for the practical, this should be able to show that you are ready to do the practical. I think I have answered the question of what the course consists. The theory is the same as last course, previous curriculum course, as heavy as that. Then we add on also some good stuff from these 2 things. And then we shall enjoy the course. You missed yesterday, was so interesting, but I'll post the video of what I went through here in terms of the course outline. Because this course is more practical in terms of applications than electricity and magnetism. Electricity and magnetism is more of an introduction of each of the parts. This one now is more critical on what we have to cover. So I will jump where we finished, and then I say last. And I will assure you that if yesterday I found nobody here, I was going to set up that stuff, time myself, teach the boy. Just for your information, that's what I was going to do yesterday. But fortunately, it's not difficult. I will close the door and talk and teach. And then I have evidence that I taught. And I will put date of 20th August.
Now it's someone.
I say I am trying, please, out of bounds, I'm trying to implement a video lecture. Because I feel cheated if I really do a lecture. If I don't come, I feel I'm cheating the government, which pays my salary. But you have been with me. Did I ever dodge your lectures?
You're cheating the government.
Yes, the government. That's their problem. You mean when you find a mad person on the street, you say, many people are mad, let me also be mad for a while. So that's if charges Q1 and Q2 at a distance R1, 2. So if we have 2 charges, I'm just drawing the diagram in an arbitrary form, and you have Q1 and Q2, and then depending on which charge is, bossy, or which charge is more influential, if Q2 is the one applying the force of the Q1, we would be more interested in R21 direction vector, whereas if charge Q1 is the one which is imposing the force on Q2, then we will be having the R12 roof as the unit direction vector, whereas the distance between the two of them would be R12, a scalar value. So this is just still a reminder. I know you are still stuck in. How many people did the school practice? Even you. You haven't changed. I was lucky that, I was happy that these kids are going to push the hell out of you. But you don't seem to have changed. Yeah, you. Yeah, normally it is the case. Because supervisors don't know you, so they see how you are trying to pick up in class. But I don't mean about the supervisors' reports. I mean the students. Did you enjoy it? They love me. So the force on Q2 due to Q1 is given by F21 is equal to KQ1 Q2 over R12 squared. And then because we are saying the charge, the force Q2 on Q2 due to Q1, it means we are looking at the force Q2 is applying on, Q1 is applying on, so we shall be using this, it will be in this direction. That will be the direction of the force. So that we say it is R, the force on the Q2 by Q1 will be the same as R12. Then this statement is wrong. The force on Q2, the force, then here we have to say it is 1, 2. And the force on Q1 due to Q2 is given by F21 would be the same as KQ1 Q2 over, doesn't matter, this is a scalar, doesn't matter if it is 2, 1 or 1, 2, it is the distance between them in the same. And this will be 1, 2 squared, and this will be R21. There's a little bit of issue to sort out in the notes, which I normally sort out, like I've sorted it out here, but I've never documented it. So I would like to document it now for the force of because I have to make new notes to fit within our course of 3112. Now I'm comfortable. The figures in it look like they are even, not the 2105 used to sound very depressing. This is a bit boring because it's repeating what you have done before, and then you feel like you are wasting time, but it's important for me. I assume I've never seen you normally, so that I can give you the much needed stuff. So where K is the 1 over 4 pi epsilon naught, which is equal to 1 over 4 pi times 8.85 times 10 to the power negative 12, being the same as 9 times 10 to the power 9 Newton meter squared per Poodle squared. And epsilon naught is called the permittivity of free space, and has a value of 8.85 times 10 to the power negative 12 Poodle squared by Newton meter squared. Okay, so we've tried out the number in the Coulomb's law, but after Coulomb's law, when we got Coulomb's law as force between the two charges, we now want that, just like when we look at, we've seen now we have a test charge Q1, capital Q, we brought in a charge Q, and then we determined the Coulomb's law. And then we determined two charges of good magnitude, because the point charge small q was said to be or looked at as a unit charge. So now we look at two charges Q1 and Q2 in the vicinity, and then we looked at when each of them applies a force on the other. Now we move on and see a bunch of charges within a given vicinity, in a given region. And to know the force on these charges and how they are interacting to each other will depend on a principle. We have to decide the principle to follow. And this is the principle of superposition. So I guess that should be about 1.1. 1.1, the principle of superposition. Now, in the due course, I think using the system, I'll make sure that I'll get time and place and go through all the lectures, the lecture notes, each of the sections, go through them and record myself and post them, or put them on a DVD and you always run on yourselves, on your own. Not for dodging the lecture, but to make sure that you can emphasize, because look, this is what I used to tell people, and I'm glad that at last some people took it up in the form of Simple Learn, which is on MTV. Although they put it on offered hours of 6 a.m. on a Saturday, these kids are still enjoying their sleep. But I used to tell people, if these fools in town can learn how to dance moves just by watching movies, why can't you learn physics by playing and replaying and replaying how a calculation is done? Why can't you understand how a practical is done by watching it being done, watch it again, watch it again, watch it again, and it sticks here? If really these guys can dance without seeing anything, but they are not even seeing each other, but they can dance in moves, why not? Why can't we make science so interesting, so entertaining, that we can move on? So the electrostatic force on the charge Q naught due to a distribution of point charges and this distribution of charges Qi, where I is equal to 1, 2, 3, and so forth, up to n of them, at a position R1, R2, R3, up to Rn, from the point charge, Q naught, this electrostatic force is a vector sum, of the forces exerted individually on the point charge Q naught. Now, either this charge distribution can be discrete, that is, we can be able to count out the associated charges, or it can be continuous, whereby it can be in any form, could be linear, like a wire, could be along a surface, or could be along a volume. So, to begin with, we shall look at the first part, 1.1.1. That is for a discrete distribution of charge. So we have the parallel. So if this is our charge Q naught, and then we have the charge Q1 in the vicinity, we have Q2 in the vicinity, we have Q3 in the vicinity, and we have Q4 in the neighborhood. These charges will all affect, and if we have, of course, this is R10, R20, R30, R4. In other words, we could have just written like this is I0, where I is 1, 2, 3, etc. So the force F is given by F is equal to the vector sum. So we are summing from I is equal to 1 up to n of k, Q naught, Q1, Q2, Q3, Q4, which is Qi, divided by the distance between any of these charges, I equal to 1, I equal to 2, 3, 4, etc. to 0. The 0 here is the knot here. And then Ri0 roof, because all these forces, this is F 10, no, well, I will start by R10 roof, this is R20 roof, R30 roof, and it is along this direction that we have F30, we have F20, and we have F10. And R roof 40. Am I doing the right thing? Because the forces, so this should be 0, 1, 0, 1, 0, 2, 0, 2, 0, 3, here. And then we have 0, 2, 0, but this one wouldn't matter. This wouldn't matter, even if I left that as 0 and 2, 0. But this matters. because of the direction of the force, as well as the direction of the indirection vector. So that's how, yes.
Is that F01? Is it force on a charge Q0 due to charge Q1 or the other way?
We are looking at Q1, and by the nature of the direction, it means that we are considering the force of this one on this one. Okay? Because of the direction of the force. For example,
force on Q1 due to Q0.
Pardon?
It's force on Q1 due to Q0.
Yes. If we write it like this. You mean where? On this one here? Now, what if this was attracting this one? Because I'm not having any value on Q1, and I'm not having any value on Q0, okay? So, assuming this is minus 1 times 10 to the power of, let's say, minus 5 microcoulomb, and maybe this is 1 microcoulomb. I don't know whether you understand my emphasis. So I don't think you should dwell so much on the emphasis of, but well, you may be right, but the idea is about the force of this on this. And it won't matter if you have Q not being or attracting this one. It means we would be having a force that is being in this direction. So I don't think the arrows should be a big deal. Or maybe to be safe, one could have said, done this and done that. But nevertheless, let's follow your wish and say 0. But look at the statement. The statement is the electrostatic force on a charge Q naught due to these charges. And that's why I used I0. Because it is these charges, irrespective of whether these arrows are outward here, it now depends on the charge that Q1 houses. That eventually matters. You remember when you had charges in electricity and magnetism, charges placed on the sides of the triangle, and when they give you the values of the charge, then you start now drawing the forces differently. That this is now an attractive force, and whichever will be more attractive, that's the direction of the force. And then finally you get the resultant forces, and then you draw your right angle, your right angles, and then find the result. On the what? Oh, you want also on the F. It won't matter so much because this is a total sum. So I cannot now write here on that IF. I mean, it is a total sum. This is already the total sum, which is the electrostatic force. This is the F, the single F, which is also, which is given by the vector sum. Okay, so where small k is equal to 1/4 pi epsilon naught. You've done this from all level. I still talk about it till today. When I become the minister of education. Oh, you think to be a minister of education is as simple as being crazy? I go back in my village and ask for votes. And all I have to first do is to say this government is bad. And start writing in papers, getting people, and then they say, but young man, what is the problem? And I say, I want to go and it's done. So then I go back to the village, they give me votes. Of course, when I come, I think I'm going to be a minister. I would also make noise like these guys who make noise. We are the young blood. We have told this thing and I think we can change. And then they give me, so when they give me, and I become a minister of education, I think you should make sure that if you have been in school, you do exams maybe once in a while always. Because these things were taught in all levels, and up to now I still teach it, where K is equal to 1 over 5 epsilon naught, 9 times 10 to the power 9. We do what? No, I should just say refer to your knowledge of all level. Now this force now, F will be equal to summation I is equal to 1 up to nk q naught qi over ri naught squared. Of course, where k is that? I'm repeating myself incidentally. And this would imply that F is equal to q naught over 4 pi epsilon naught. So we put in for i's q1 over r10 squared plus q of then r10 roof plus q2 over r20 squared r20 roof plus you can go on and on and on until n of them qn over rn0 squared rn0 roof. But we know that from electricity and magnetism, this expression is the same as electric field in NZ. So, of course, including this part here. So we shall say that F is the same as Q naught E, where E is equal to 1 over 4 pi epsilon naught, so we can say any point P. Summation I is equal to 1 up to n Qi, because 1, 2 up to n was the same as Qi over Ri squared Ri roof, where EP is called the electric field at P. No, most of you are there, amazing. So that was for discrete distribution of charge. So 1.1.2, we look at for a continuous distribution of charge. So I'll put that value on the web for the assistant. So the linear distribution of charge in discrete form as summation I is equal to 1 to n of qi over ri squared ri roof will now the sigma will change into a snake, which is the integral, and then that integral will be along the line. Just like you had to count all these charges up to n of them, now you'll have to move along the line, and then you'll have your other roof over 4 pi epsilon naught r squared lambda dl. Because now the charge, actually there should be a 4 pi epsilon naught here. The charge Qi is now the same as the charge density along the line of charge multiplied by this elemental. And then when you integrate, you get a total length along the line times the charge density, you get the total charge housed within the line. So where lambda is linear charge density, and this would imply that EP is equal to 1 over 4 pi epsilon naught along the line r roof r squared lambda dl. So let's define the r roof. I know it is time, and I'm more hungry than you are. Is the unit, because I eat a lot, from element of charge, dl to the observational point r, point, and r is the distance from the element of charge to point P. So we shall construct our ideas more when we meet next time. So any questions? Anyone having a collision for our schedule? Yes?
That's it.
The statement is R roof is the unit vector from element of charge here to the actually I should have put it there that this is P X Y Z. Then this is our R roof, and then from element there, observation point P. So maybe we want to see P, observation point P, and then R is the distance from the element of charge to P. So R is from here to here, and then this roof is the direction from element of charge to the observation point.
In my opinion, I think DL stands for the elementary length of the charge, because it's a linear distribution.
Well,
it's element of charge here. I can't make out what it means.
Ah, okay, sorry. I don't think it matters. Maybe you wanted to see dq, but after all, you know, dq is the lambda dl. So, but that lambda dl, the dl, the element, is the one which causes the element of charge. I did not say elemental charge, but element of charge, dl.
And they say lambda is the charge density, meaning it's charged by unit.
I'm noting that question. Yes, this is charge density. Lambda is equal to is the Q, charge density, dq, yeah. Okay, so I would have loved to start from Gauss's law. So you read about the surface charge density and the volume charge density, and we start from the Gauss's law. Because I say, by the way, when I say 10,000 per hour, I don't know how you will count your hour, because it is not that when I come is an hour, I'm not working for an hour. So